Yes.
So what now?
So from there, we would use mesh
Why
analysis.
why are you going two different directions here? You can't go two different directions with the with the meshes. You gotta be one uniform clockwise direction. That means you gotta get rid of this arrow right here. It's going wrong.
That one?
They gotta both go this way, clockwise.
Oh, I got rid of everything.
Right.
I thought this would go this way because the arrow is going up.
You're not following the arrow. The arrow gotta follow you. We're taking clockwise for both of them, right?
Yeah. So this is
Always.
I1. This is I2. So we find wait. So this would be 6 times I1 plus 4. What's a 4? 4, yep, 4 ohms times I1 minus I2 equals 0.
About the voltage source. How about 28 volts?
Times 28 right here.
Yes. Times, why times? You gotta say minus 28 volts plus all that, right? You're coming out of the source, you're adding these, you're, you're subtracting, you're saying minus 28 for the active sources, or for the active sources, or for the active elements. And then you use positive for the passive elements, right? So the
Right.
resistors are passive elements. The source coming out of the source is from the positive out of the source, conventional flow. That's a
Negative.
active element,
Oh.
right? So you gotta say minus 28, right? Plus all of that equals 0. That makes sense now. Minus 28 plus 6 I1 plus 4 I1 minus I2, right? So now what?
And we know I2 equals 6 amps.
I2, is it really 6 amps? Where is
Negative.
I2 6 amps?
Negative 6 amps.
Where is I2?
Right here.
They say it's I1, they call it, right?
Yeah, they're calling it I1. So I should have changed this to I1 and I2 here.
Yes, yeah, I agree with what they're saying, right?
So then I would have to, these equations would be
So
flipped.
I1, wherever I1 is, all right, just change this to I2 then. Just change the 6 amp to I2. The one
Okay.
that's it. This one, this one.
Mm-hmm.
God have mercy. What we did?
You're still there.
Okay, so that's turns I2.
Mm-hmm.
So then what? It's not even true I2 because it's gonna be negative and
Negative,
I2 is
yeah.
negative 6 amp, right?
Mm-hmm.
Exactly. So now you can substitute I2 in the equation.
Yeah. So now we got negative 28 plus 6I1 plus we have 4I1 minus 6 times 4 is 20. 24. So it'll be 24. Wait, this was what? 4 times I1 minus
Mhm.
um negative
So it's gonna turn plus, right?
24. Yeah.
That's gonna turn plus.
Yeah.
You see why?
Because it's negative 24. It's minus negative 24.
Right. So minus minus become plus.
Mm-hmm. And
You
then
know what?
from there, we can do 6. Wait, that would be 10 I1 I1 equals
I2.
24.
Well, everything is I1. You work it out. Right. So you plug it in. Okay.
24 minus 28, which would be negative 4. So that 10 I1 equals 4.
Count the 28 in there already.
Yeah, 28 plus negative 28 plus 24 is
Mm.
negative 4, and then you bring it to the other side. So then this would be divided by 10. Divided by 10. So I1 equals 0.4.
0.4.
Yeah.
All right. So what is R thef, V thef?
So from there, V theb, and we've got R theb, and we calculate I1 and I2. So V theb what is that
First,
number?
highlight where V thef would have been regards to the original diagram.
So V theb would be, because you short this out, so it would be the
You
voltage
keep saying short out.
across.
You did not short it out.
Open the circuit.
It's not the same. It's opposite. It's the
We
exact
open
opposite.
we open the circuit here. So the V that would be the voltage across this resistor here.
The 6 ohm.
The 8 ohm.
There's no 8 ohm. Can we take it out, right?
Yeah, so it'd be this voltage across, like this voltage here would be the VTEV.
So which resistor is there?
R2,
Which is what?
6 ohms.
So only the 6 ohm will be considered. Is it that means whatever is across the 6 ohm will be V thef. In other words, what do you find across V thef? Across the 6 ohm.
I1,
One is
which would,
flowing through there. So how do you find the voltage across it?
so it'd be 28.
Mm-mm. Well, no, you don't. Where's I1?
I1 is right here.
What is I1?
I1 is 0.4.
Okay, so the voltage across the resistor will be the current through it times the resistance, right?
Resistance. Yep.
Yeah, and it's the same thing as VTEV because it's
Oh, so
VTEV is right across here. If you look on the line, you'll see that all this is still VTEF across this. It is the same point, right? So VTEF is right here, right? Across the resistor, across the 6 ohm resistor. You see that?
Mm-hmm.
So you do IR, and that's the VTEF. All right?
So it would be 0.4 times 6 ohms.
That's that.
6. That would be 2.4.
2.54 volts. Exactly right. All right, good. No, that's that. So you think you get it now, or you need one more for practice?
Yeah, I think. Yeah, maybe we
I
could do
think
one more for practice.
I'll do one more.
'Cause there were a lot of them on there. So the current always goes either both go clockwise or both go counterclockwise.
It's always clockwise.
It's always clockwise?
Always clockwise reference. Just choose a reference. It's going to be always turning clockwise. So if there's a current source pointing in the opposite direction, that's going to be negative. Otherwise, it's not going to come out right, right? If they're flowing in opposite direction and all, right?
Okay.
The values are not going to come out right. All right. The other thing you might be able to do, let's leave the Thevenin, is the source transformation, right? We
Okay.
call superposition. You understand? Where if you have a source here, a resistor here, a resistor here, another source here, right? And a resistor here. Now another resistor here. This is a 2 ohm resistor. This is a 2-volt source, right? And then this is a 4 ohm source, 4 ohm resistance, and this is a 5 ohm. And this is 1 ohm, and this is 6 ohm. All right. All right. So this is a 2 volts. This one is a 60-volt source.
Oh, wow. 60 volts. Jeez.
That's nothing. You're a power engineer. That's nothing. Talk
Huh.
about 600K or 500K. Then I
Hmm.
talk about voltage. All right. Now, guess what? What we need to do is superposition, right? And guess what superposition states? Superposition. And I mean, you could use loop analysis to solve this problem as one methodology, but you could also use the principle of superposition. What it states is that you can lock down one source. Just if it's a voltage source, the same thing. You short circuit the voltage source, right?
Okay.
You understand? You could short
Understand.
circuit the voltage source, one of the voltage source, and then use the other voltage source to work the circuit until you find whatever you're looking for. For instance, we need to find, let's say the voltage at this point, right? So we're looking at VA. We're looking for VA here, right? So we could short circuit this voltage source first and then work the circuit and see what VA is. You understand?
Mm-hmm.
And then when you do that, you short circuit this voltage source and work the circuit again and find out what VA is. And then when you finally get to both VAs, you add them up. And then that should give you the voltage at VA. You understand?
Okay.
In other words, let's do it. We can remember they say always short circuit the voltage source and open circuit the current source, right?
Mm-hmm.
So in this case, we're gonna short circuit the 60 volts and use the 2 volts only. So here, resistor, 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 and then resistor, short circuit. See that? And then resistor. So this is a 6 ohm. This is the 1 ohm. That's short circuited. This is 5 ohm. This is a 2-volt source. Understand? So this here is a 2 ohms and this is a 4 ohms. No, you can work this circuit first. This is another method called superposition, which is what we're doing now. You work one source, short the other source. If it was a voltage source, if it was a current source, you open it, the other source, and you work the circuit till you get a voltage, which is what we're looking for, the voltage at this point. V sub A, right? You understand?
Yes.
So how do we find VA?
So we could use mesh analysis to figure out what the voltage is at that point.
Yeah, that's how we need to find voltage at that point.
Thanks, Sophie.
So 6 and a 5 in a parallel here.
6 and the 5 are in
Let's
parallel.
say have the 2, 4. As a matter of fact, if you do the mesh, do the loop going in, right?
Mm-hmm.
For the 2 volts for the first loop, then what?
Would you do
What's
the
gonna be
2 volts and the 4 volts in parallel first?
no, what I'm saying you could just do a loop analysis with the 2 and the 4 ohm and the 5 ohm with the 2-volt source and loop 1. Right?
Right.
So what's happening there? This is gonna be 2 because it's coming out then. We're going this way. No, we're not coming out of the positive, we're coming out of the negative. So we're gonna say 2 instead of -2, right?
Mm-hmm.
Plus what?
Plus 2 ohm.
How about here?
Oh, you
Going
want to do that
clockwise.
one first? Oh, so we do the 5 ohm
5 times I
I1
then fine
plus
plus
I2.
plus what?
The I2.
Where is it I2?
You wouldn't consider the current going through the second loop there?
Is that current going?
The I2
Right here?
current, yeah,
Right here?
the second
Is it
loop.
okay? Is there a current there?
Oh, you're not considering it because we shorted the voltage source. Is that why?
Yeah. Why if you're looking at it, a loop analysis like that, okay, let's say it's a loop, let's say there's a current, then what? Let's say there's a current. Treat it like a current, then what?
So it'll be 5 times I1 plus I2.
What is I1? Is there I2? Because remember it's the same source, right? They're getting the feed from. So there's no need to do that, right? If you're doing that, right? There's no need to really say that. because what? What if you parallel these two resistors? What's that? 6 times 5 over 11, right?
Mm-hmm.
Then
Wait,
then then whatever the voltage is here, that would be what? 11 ohms. Then what? Then these two, what gonna be a voltage divider, no? Or better yet, it's gonna be the voltage here at this point is gonna be what? 5 ohms over 5 plus 4 plus 2. That's 11, right? 5 plus 4 plus 2, 9 plus 2, 11 times 2 volts. Right? How much is that?
5 over 11 times 2.
Yeah.
That's 2. So that'll be 10 over 11, which would be 0.91.
Hmm?
0.91.
0.91 volts.
I don't get how we got that.
Well, you don't get it.
So you did 6 ohms times, so you,
I did 5 over yeah, so that 5 over 11. The 5 ohm resistor, right? So
Mhm.
times is sum with the other resistors, right? 4 and the 2 is 11, which is on the other side at the divider. The voltage across here and the voltage across here is the same thing. That's why I didn't consider both of them, right? So if we could just say 5 volts, 5 ohms over 11 times the 2-volt source, that's going to give you 0.9. And then 1.1 would be across the 6 ohm, right? Together, you see? You did a voltage divider again. So VA is equal to 0.91. You did the 5 volts here. You did a voltage divider, which means that if this was R1, R2, and R3, that means the voltage across, which is VA we're looking for, is across R3, right? So we'd have to say VA equal to R3 over R2 plus R1 plus R3, right? And then that's how you plug that in and you multiply that by the 2 volts. And then that gives you 0.91. Now you'd have to do the same thing, this time with the 60 volt source though, right? You'd have to turn off the 2-volt source and turn on the 60-volt source. So you're gonna have to next time short circuit this. Short circuit this 2 volts. This will be VA again. Right? And then this time though, you include the 6 ohm and the 60-volt source only. You don't include the 2-volt source. And then you work this out. This is 6 ohms. This is what?
5
This is
ohms.
5 ohms. This is 60 volts. There's a resistor down here though,
Yeah.
right here.
1 ohm.
It's 1 ohm, right?
Mm-hmm.
The 1 ohm resistor here. All right.
Yeah.
So now what? This is 4 ohms.
Mm-hmm.
And
And then
this one
2
is what?
ohms.
2
2
ohms.
ohms.
So what, as we were saying though, now you could do the same thing here, right? Because to find VA, there's several ways you could do it, right? As I said though, the voltage here across VA is going to be the 5 ohms again, right? Over this piece here. We don't have to consider everything. You could just consider this piece where the source is, right? Because the voltage across all this is going to be the same anyway. So it's going to be 5 volts over 5 plus 1 plus 6. And multiply that by 60. So 5 over what? 5 and 1, 6 and 6, 12, right? Is that 12? 5 over 5 plus 1 plus 6.
12, yeah.
12. I multiply that by 60. How much you get?
Oh, times 60. 25.
So it's 25 volts. All right, so that is VA2, right? This one is VA1, right?
Mm-hmm.
So what I say you gotta do with both of them? You gotta add them, right?
Mm-hmm.
So that is what? 0.9,
Mm-hmm. That's
1
25.
amps plus 25 point what?
It was just 25.
Okay, that is equal to how much? 25.9
25.9. Yeah.
volts. That makes sense?
Yeah, it makes sense.
Yeah. Right. Okay, what you've been reading now? What I told you to look at last time.
You were supposed to send me some questions.
What I was supposed to send you some question, what did I tell you to read
Yeah.
upon?
I think that was it. Let me reread my notes. I thought we just
Let me see something here. All right, let me see. Compose. Let's see what this.
look at homework next week. Yeah, it says
What
you're gonna
homework?
do
Come again?
you were gonna send me some math and so in circuits.
I sent you some circuits already, didn't I?
I don't think you did. Did you? Or
Did I
maybe you
send
did
some
when I was on the
circuits?
maybe you did. Oh no, did I miss it? Dean.
I'm gonna send you some notes based on what we just some of this stuff. Nodal analysis next. You could look at that. We'll look at, no, we did know that already. We did some multiple sources. So anyone readings on that?
Oh, you did send it to me. You sent me electrical homework. Yes, you did. Shoot.
Was it electrical? What did I send
Yeah,
exactly?
it was 12
Is it
pages of
circuits?
electrical circuits. Yeah.
Is it Q&A? Question and answers?
Yes. First one was mean standard deviation, probability.
Okay, see, I knew I did.
Probability. Yeah, I'm sorry. I don't know how I missed this.
It's fine. You can solve it now.
It's yeah, so
So
I'll
can
send
work
this
that the
to you.
next time. But I'm gonna send you some notes, some more notes. So notes on Kirchhoff's law. Get familiar with that plus multiple source. Let me see what else notes. I said in the RLC notes already, right?
Yeah,
Okay.
RLC circuits. Yeah,
Capacitance.
I did look at that a little while ago.
Yeah. All right, so you're gonna try those questions and get some notes, right? I'm gonna give you some notes. So the question will be on econ. We didn't do no econ yet, right? Again.
No, no.
So we need to slide. The next time we gotta jump. As I said before, I wanted to get circuits. Obviously, because if you cannot answer circuits, it don't make no sense, right? Makes
Hmm.
no sense whatsoever if you cannot do circuits. So I'm gonna send you some notes. You can sit and read through the notes too if you want. Additional notes from some other professors I got before. So Kirchhoff's law, multiple source, capacitance is a good one. That's good. And um,
You there?
can you hear me?
Oh, I was missing you for a little bit.
And
I
then
think I
and
hear
then
you
there's a
now.
cir and then there's a circuit analysis homework, right? That I just sent you to. Okay, you there?
Oh, okay. Yeah, I'm here. Yeah, sorry, I was losing you for a little while, but I have you now.
So then I'm gonna send you some circuit analysis homework. Then you're gonna read up on multiple sources, Kirchhoff's law, right? And try to solve those four problems that I sent you. Okay,
Okay.
see if we can answer them better than my students.
Mm. He said they're giving you a warm time.
No, they're all right. They're good
It
kids.
can't be as bad as me.
Yeah, don't worry. I enjoy your trouble a little bit.
Mm.
You're not too bad. You just need to stay active. Unless I realize if you don't stay active, you lose it back here. So you
I
gotta keep you
know.
busy. We
It's
gotta keep you busy.
too quick, right? Too quick. It just disappears. It's
Yeah,
gone
you
into
gotta
the
you
abyss.
just pass it, take it in and pass it out. They're like, okay. But you know what? You're gonna retain it the more you practice. You understand? So I just send you homework for plus the work that you have before I sent to you that you didn't do. Plus you have 23 multiple source resistor, you have Kirchhoff's law and capacitance to go to scan through. You understand? So you have plenty to do, right? So you're gonna read up on, I told you to read up on economics and materials, right?
Okay. I need
Also,
economics.
and materials, electrical materials. So you're fully loaded now between
Yeah.
economics and materials, plus the Kirchhoff's laws and the capacitance and the multiple source and the homework, plus the exam. So the test I said, the homework I sent to you before. You are fully loaded.
Mm-hmm. And you sent me 2 more questions. Four more.
So just do the best you can out of that, okay?
Okay.
And see how you can accomplish. See what you can accomplish. My friend Samara.
Hmm.
Hello, Samara. How is your day?
Good.
How was the day?
Great.
Work hard today?
Busy, busy. Yeah. We're pretty busy
Stay,
right now.
stay busy, huh? They got you busy doing a
Yeah.
lot of projects and everything.
Oh, yeah. Got lots of projects. It's okay.
Man, that's work, ain't it?
Yeah, it keeps it interesting.
Okay.
Wouldn't be fun if it was slow and dead and there's nothing. I'd lose my mind. So you're the same way. You're there, here, there.
Yeah, try. I guess we stay active, don't we?
Yeah.
Oh
Mhm.
boy, that's
So when do you go
life.
into the US?
Why I need to come to the US right now?
I'm just curious. I thought you normally come up. Well, you
I
missed the
have a few
summer.
words, baby. You gonna come look for me? Come to the US? Uh, I'm not. I'm gonna take a little while, maybe a couple more months. I'll see. You know, I'm an open citizen, and I pay my taxes. That's all I really need to do for not to stay away for a little bit. You know,
Oh, right.
once you pay your taxes and yeah.
Oh, so you don't have to come back like every 6 months or so?
Right, because I'm not green card. I'm a citizen, right? So
Oh, okay. I didn't realize if you're a
yes,
citizen, I thought you still had to come up ever so often.
yeah, nah. Yes, citizens living of America living all over the world for years. You don't have to. When you're a green card holder, you gotta do that. Trump is trying to flip things, but it's not working. It's not gonna work like that. I know he's
Mm.
doing a lot of changes, but I don't think it will work like that. So. Did you get the homework? I just sent that home.
It usually takes a little while to come. It'll
Oh yeah,
come.
you
You
gotta go
sent
through the
it.
documents.
Yeah.
Okay, well. All right. How much you owe me now? 1 million? That's
It
one
was
hour there.
just for today, right?
Nope.
Yeah.
Plus Thursday, right? Wednesday. Remember
No,
35?
I thought I had.
No, you did. We recorded it. Remember? The last one we recorded and say
Oh, the last
right
one I
here.
put in 052.
No,
Oh,
not
I did
52,
52 and I
35.
said I owe 35. Okay. So
35.
35 plus 35.
Yes.
Okay, because the other one I said paid. But
Yeah.
then I.
So that would have to be 70. You know
Mm-hmm.
where to go? Remember the site? The site.
I got it.
GCECC. Oh, you got it.
Mm-hmm.
That's good. Good that you remember how.
Let me know if you have any questions. No, thank you.
If I have any questions.
No, that's
Oh,
it.
I have questions. I need to see you all night. Okay, that's good. Conspiracy tonight.
Hmm.
Yeah.
Oh, yeah. Yeah. I didn't even notice that. I did not notice. Okay. Gotta get
So
to
what you
all
gonna do
this
now? You
homework.
going to bed? Must be
Yeah,
tired now.
maybe another while. It's still early.
Ah,
Still a little early.
so what you gonna stay up doing? Taking care of the little ones? You gonna-
What I've been doing is when we finish up, I just review a little bit of what we talked about.
Okay. Did you download that? So
I
you should
did, yeah.
download that already. Okay. That's good. Well, that's it.
Mm-hmm.
So, okay. Did you try the process a while ago? Did you try to process the payment a while
I'm
ago?
still working on it. Yes, I gotta fill out all this paperwork all over again.
Was a lot of things on there?
Yeah,
Oh
I got
God.
your assignment though.
You got the assignment? That's reaching?
Yeah, it's here.
Good. So you'll be busy. You'll be
Yes,
busy for sure. And busy is good because we don't want you to forget.
I know.
Understand? All right, so
I don't know why I didn't. Hold on. I was trying to finish this before I get. Oh, okay. I needed to put a note, and
we have
without
to
the
put a note.
note, yeah, it wouldn't allow me to go. Like the last time, this screen was blank for a little while. Hmm. Think. Let me know if are you able to tell when you get it?
Usually, the last time it take one day, the next day after.
Oh,
Usually
okay.
take a day to process.
Oh, okay. So I think it didn't, the screen went blank, so I'm assuming
What
that
I mean?
through.
But the screen went blank.
It's, yeah, I don't know.
Uh,
I think it went, but, oh, okay. It
oh,
was a screen that came up. Close, close. Yeah, it's acting up. Let's see if I turn it this way. Oh, okay. So that's what happened. It's not now.
the
Okay, so it
knockout.
live stream. So it seemed like
Oh yeah,
it
you
went.
received payment. I see something. I got an email. I got an email that says receive payment. You received payment.
Oh, okay. I don't
So
know why.
it's processing.
Yeah, I don't know why it was timing out like that. But I'm glad you told me that.
Yeah, I got it. Yeah. All right. So you're gonna do what you do, huh?
Absolutely.
And in between, you don't hesitate. You can give me a call in between on the WhatsApp when you get a chance. If you know what I mean, like maybe when you're working a program or whatever, if you want to talk a little bit about it, you can give me a call.
Okay.
Don't ask too much deep questions on this while I'm on the streets because I won't be able to help. But like a scenario, if there's certain things and the questions that maybe I can help you with at any point. Right. What next? We go to your bed now?
Yeah, in a little while.
Or do
How
some
about
work?
you? You gotta go to bed so you can wake up early, right?